We shall now discuss a little bit about the exit function through an example, as well as I am going to talk about the continue statement or the continue keyword. First thing, let me tell you a little bit about the exit function. The exit function prototype is declared in a header file called as standardlib.h. As the name indicates, it causes immediate halt or termination of the entire program, and the control goes back to the operating system. The break gets it to the next statement within the same program, whereas exit completely gets the execution out of the program and the control to the operating system. Now, this is how exit, or this is how it is written, void exit in return code. This thing will be clear once we take a look at functions. Now, along with exit, you can return certain numbers. If I say exit 0, that means I have returned without any problems. Exit 1 could mean some problem. Exit 2 could mean some other problem. So any non-zero values could indicate certain problems when you're trying to quit that particular program. Now, what happens is these return codes are mostly dependent on the operating system you're running on the program on. So, for example, 1 may indicate some problem reading the file, 2 may indicate some problem with something else. So, these codes may be used by the operating system and sent by the calling program so that the operating system can handle that particular error. For example, I had already told you an exit of 0 means that the program finished normally. Any other non-zero value indicates that some error or unexpected behavior or unexpected results really took place. The prototype or the model of exit function is declared in standard library.h. I am going to use the same function to determine whether a number is prime or not to explain the exit function. So if you see here, before I can use exit, it is required that I declare or include this header file called as standardlib.h, because the model of this particular exit function is declared in standardlib.h. Rest of the things are same. So this particular program, I'm also doing the same thing, trying to find whether a number is prime or not. Except that when the number is not a prime number, like say 21, when it hits the exit, it will straight away controls goes to the operating system. It will not go and try to check this if condition. Whereas if you had a break, the break would have only got it outside the loop, whereas the exit totally quits the program and goes back to the operating system. So that's all you really need to know about this exit keyword. Not going to be used very frequently. You're going to use break more often, but not a bad idea to have an idea about it. Now let's take a look at this continue statement or the continue keyword. This is one you may tend to use once in a while at least. So let's first try to understand the code and then go about trying to look at the theoretical concept. That's always easier to understand. I believe whenever you hit a concept, look at the example first, try to understand the example and then go to the theory. It's always easier to understand the theory that way. So here what I have done is I'm trying to demonstrate the use of the continue statement or the continue keyword. For this, you don't need to include any header file because continue is a keyword. It's a part of C++ language. So here, if you take a look at this program, what I'm trying to do here is I'm starting the value of I equal to 10. And as long as it should not be n, this should be I. All right. Sorry, pardon me for this mistake. This should be I. As long as I is greater than 0, I am executing this particular statement. This should again not be n, this should be I. So let me explain what this program is really trying to do. I is 0, forget it. But I am reinitializing I to 10. This happens the first time. As long as I is greater than 0, I am trying to execute the body of this particular loop. So 10 is 10 equal to 5. This is false. So it will print 10. Then I reduces, it becomes 9. When I becomes 9, alright, when I becomes 9, 9 is greater than 0. 9 is equal to 5. It is false. So it will print I. It will print 9. Then this way I gets reduced. It becomes 8. It becomes 5. It becomes, sorry, it doesn't become 5. It becomes 7. Let's say I is 6. 6 is equal to 5 is false. So it will print 6. Now from 6 I becomes 5. Once I becomes 5, 5 is equal to 5 is true. Then what happens is this continue gets executed. What continue does is any statements or any instructions after continue do not get executed. So none of these, the value of I when it is 5 does not get printed here. That is the reason, because any statements after the continue do not get executed. Then we go back to I here. I becomes 4. 4 is equal to 5 is false. So it has printed 4, 3, 2 and 1. So the moral of the story here is after continue, none of the code is executed. The control goes straight away back to I minus minus. Now let's try to understand the theoretical concept between of continue keyword. Continue is used to skip the rest of the code in the loop for the current loop. You have seen the continue is used to skip the rest of the code. Now the control goes to the back to the top of the loop where the increment decrement happens, or where the condition is being checked in case of a while or a do while loop. So advantage is you can skip any keyword, any code after the continue keyword only in the current loop or iteration. Continue will only do it for that value when that if condition happens to be true. Let me give you an example now. Suppose I hide this if, okay, and this continue is there. What do you think is going to happen? It is not going to print any value between 10 to 1, because after continue there is a cout. That cout is never going to get executed. So I hope this clarifies the understanding of continue keyword, and with this we have wound up the theoretical discussion about control statements in C, like loops, decision making and so on. Please make an effort to understand this chapter very well, because this is a really important chapter, because it's common to every programming language you're ever going to learn in your life. I'll also be doing a live demo of a number of programs, especially your lab programs, so you will get better clarity when I try to explain online.